Nearly half of the gold in the world is stored in the form of bars, and each one can be worth hundreds of thousands of dollars depending on its weight and purity. Because of this, they are kept in some of the most secure vaults on the planet. But how is a gold bar actually made? To find out, let's travel to Switzerland and explore the process. Since ancient times, gold has symbolized wealth and power, but transporting it in irregular chunks made it hard to use. In Roman times, the first uniform bars were created to make trade easier. Later, during the Middle Ages, smelting techniques were improved, giving rise to the trapezoidal shape that is ideal for storage and efficient handling. With the gold rush of the 19th century, weight and purity standards were established, solidifying the design of the bar we recognize today. Its shape is not random. It allows for safer and more practical handling. Today, gold bars are essential for banks and governments as a store of value. But how is the world's purest gold obtained? The process begins with locating the deposits, which may be found in underground mines or open pit operations. In underground mining, tunnels and galleries are built to reach deeper veins with higher gold concentrations. Open pit mining, on the other hand, involves removing large volumes of surface soil and rock, making it more efficient for shallow deposits. Once extracted, the material is transported by truck or conveyor belt to the processing plant, where it begins its transformation. The first step in the plant is crushing and grinding the ore. Crushers of various types, like jaw or impact crushers, break the rocks into smaller fragments. Then, the material is passed through ball mills or rod mills to grind it into a fine powder. This is a key step because reducing the size of the mineral exposes the gold, allowing it to be separated from the other components in the rock. This is where the magic of modern metallurgy begins. Crushing the ore isn't enough. Every particle of gold must be released efficiently. It's like tearing apart a loaf of bread to find every sesame seed. The finer, the better. After grinding, the process continues with cyanidation, one of the most widely used techniques to extract gold. The powdered ore is placed into large tanks filled with a diluted solution of sodium cyanide. This solution dissolves the gold, turning it into a liquid compound. To make the reaction more effective, the pH is carefully adjusted, and oxidizers such as oxygen or hydrogen peroxide are added. This step is critical as it allows the gold to shift from solid to liquid form, preparing it for recovery. At this stage, the gold remains dissolved in the cyanide solution, so it must be extracted through precipitation. A reducing agent, usually zinc powder, is added to trigger a chemical reaction. As a result, the gold separates from the solution and settles as a golden sludge. Other metals like silver may also precipitate if present. Once this gold-rich sludge is obtained, it is filtered to remove the liquid residue and produce a solid concentrate. This material becomes the base of doré, an unrefined alloy that will be purified later. The next step is smelting, where the golden sludge is placed in an industrial furnace capable of reaching temperatures above 1000 degrees Celsius. Under extreme heat, the gold melts and separates from other metallic and non-metallic impurities. Since gold is denser, it settles at the bottom of the crucible, while the lighter substances float to the top and are removed as slag. Although the molten gold is already relatively pure, it can still contain small amounts of other metals. To reach maximum quality, it undergoes a refining process, which can be done through electrolysis or advanced chemical methods. In electrolysis, the impure gold is placed as the anode in a special solution, while sheets of pure gold serve as the cathodes. When an electric current is applied, gold ions migrate and are deposited onto the cathode, resulting in a metal with purity exceeding 99%. This is where precision makes all the difference. Refining gold is not just a technical procedure, but a meticulous task where every detail counts. A slight adjustment in acid concentration or electrical current can determine the final quality of the metal. That is why the combination of science and precision is essential to produce gold that is ready for use in jewellery, technology, and other industries. Another method for refining gold involves the use of acids in a procedure known as aqua regia refining. This technique consists of dissolving the impure gold in a solution made of nitric acid and hydrochloric acid. effectively separating impurities and producing extremely pure metal. Thanks to this process, the refined gold meets the high-quality standards required for commercialization and use across various industries, from luxury goods to cutting-edge electronics. Once the gold reaches the desired level of purity, it is carefully poured into molds to give it its final shape, ensuring efficient handling and transport. This step not only defines the bar's appearance, but also guarantees its structural quality. The molds, typically made of graphite, are ideal due to their thermal resistance and chemical neutrality, which prevents unwanted reactions with the molten metal. Their surface also allows the gold to be released easily once it solidifies, avoiding sticking that could affect the final shape. To achieve a flawless result, the pouring must be carried out with precision, minimizing the formation of bubbles or defects that could compromise the bar's integrity. After being molded, the gold goes through a cooling process. This can be done gradually at room temperature to promote uniform solidification, or through rapid cooling known as quenching, which involves submerging the bar in water. This method not only speeds up the process but also helps refine the internal structure of the metal by preventing the formation of large crystals. Once hardened, the gold bar is removed from the mold, fully cooled, and prepared for the next stages of processing and storage. The final step before distribution is a rigorous inspection to certify its quality. Each bar undergoes visual examinations and advanced tests such as spectrometry to confirm its purity and rule out any defects, porosity, or traces of contamination. Its weight is also meticulously verified to ensure compliance with international standards, such as 1 kilogram bars or 400 troy ounce bars used in financial reserves and large transactions. Only those that meet all criteria are stamped and stored, ready for global trade. Once the inspection is passed, each gold bar receives an engraved marking with key information. This includes the exact weight, the gold's purity level, and the official seal of the refinery or manufacturer, ensuring authenticity and traceability. In many cases, a unique serial number is assigned to each bar, allowing it to be tracked and recorded in audit logs. At the end of this process, the gold bar is fully certified and ready to be sold across various sectors. These bars, backed by strict quality standards, are highly valued by investors seeking a safe store of value, by financial institutions that use them as reserves, and by industries that require high-purity gold for manufacturing fine jewellery and advanced electronic components. Beyond ensuring quality, this certification reinforces confidence in their use within international markets and high-value transactions. Once melted, inspected, marked, and certified, the bars move on to the storage phase, a crucial step to preserve their integrity and value. They are secured in high-security vaults, specifically designed to protect them against theft, physical damage, and environmental factors that could compromise their condition. These facilities are equipped with strict security protocols and constant monitoring, ensuring that the gold remains in optimal condition until it is distributed or used. The vaults used for storing gold are equipped with sophisticated security systems, including biometric identification, continuous video surveillance, motion sensors, and highly trained security personnel. These installations may be operated by banks, government entities, currency exchanges, or private companies specializing in the custody of precious metals. More than just storage units, these are modern fortresses where every detail is designed to minimize risk. From reinforced doors with timed delays to multi-step access protocols, entering one of these vaults is almost as difficult as leaving with a gold bar without authorization. For storage, the bars are placed on reinforced shelves or in compartments designed to bear their weight and facilitate organization. Each bar is arranged with its identification clearly visible, which streamlines the auditing and inspection process. Conditions inside these vaults are strictly controlled in terms of temperature and humidity, preventing label damage and ensuring the metal remains in optimal shape. The rectangular and standardized design of gold bars responds to the need for easier handling and storage. Their flat surfaces and well-defined edges make them easy to stack within vaults, maximizing space and simplifying inventory control. This shape also facilitates transport, allowing for faster and more precise handling compared to irregular formats. Each stored gold bar is logged into a digital management system, ensuring full traceability and meticulous inventory control. These records include detailed information such as weight, purity level, serial number, and the date of deposit, guaranteeing transparency and trust in the custody process. And that is the full process behind the production of gold bars. What do you think about it? Let me know in the comments. If you enjoyed this video, don't forget to hit the like button and subscribe to the channel so you won't miss the next one.